All right, so we're going to take a look at coordinate proofs. We've done everything you've done in this unit to get to this one question. Now, this one question that you have is actually a geometry question. So I'm going to give you the geometry work and just focus on how to do the algebra. But when you get into geometry, they're not going to tell you what I'm telling you here. Okay, you're going to have to know it. All right, so here are your steps in order to do this. Here are the formulas that you need in case you don't know them. This part right here is geometry. So if you had to prove figure has congruent segments, so the word congruent means the same, use the distance formula to show equal lengths. If you had to prove that it has parallel segments, use slope to show that the slope has the same value. So we've done that before. We've also done that as well. You need to show a figure has a right angle or perpendicular. So in geometry, it's not going to say right angle, it's going to say perpendicular. What that means is you're going to do the reciprocal, which means flip and change the sign. Again, we just did that. Figure has segments that bisect. Again, these are all geometry words, segments, bisect, all geometry words that you're going to learn. All this means is you have a line that's cut in half, use midpoint. Okay, so again, these are geometry words that geometry is going to focus on, and I'm not focusing so much on that. So I'm going to tell you what you need to do to prove each thing. That way we don't do the geometry, but when you get into geometry, that's what you're going to be doing. All right, so let's look at the bottom on the left. Use the diagonals to show that this quadrilateral, boom, 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 is a rhombus. Again, this is something you're going to focus in geometry. So in geometry, they're not going to tell you the parentheses because I'm telling you exactly how to prove it. But in geometry, you'd have to know, hey, if it's a rhombus, what that means is all sides are equal and the angles are not 90 degrees. Because what a rhombus is you take a square, that's not a square. I don't know how to. That's a square, and then you slant it to one side. So what happens is the 90 degrees on each square become less than 90. But again, that's not important here because I'm just teaching you the math. Okay, so all you need to prove is whatever's in the parentheses, which says all sides are equal. So I need to find all the sides, and the angles are not 90 degrees, and I need to prove that the slope are not reciprocals. That's what I'm doing. So anytime you're starting a proof in geometry, you're going to draw and label the figure. Okay, so let's go ahead and do that. So we have the point -1, -3. Okay, so -1, -3. And as you are drawing these, put in the letters. So this is A. B is 4, 2, so 4, then 2, that's B. C is 3, 9, so 3 and then 9, that's C. And then D is -2, 4. All right, so again, remember what I said, a rhombus is a slanted square. So it should look all the same distances, just slanted. So if you look like this, see that? It looks kind of like a square, but it's slanted because the angles are not 90 degrees. All right, so again, you've drawn the figure, so this is what you're going to be doing. State the formulas that you're using. Okay, so let's think about that. What formula do we need to prove that all sides are equal? Like this side is equal to this side is equal to this side is equal to this side. Well, you should say the distance formula or Pythagorean theorem. Anytime it's in a coordinate plane, I'm going to do Pythagorean theorem because it's faster. But if you want to do label x1, y1, then x2, y2, by all means do that. For me, I'm going to stick to Pythagorean theorem when I'm in the coordinate plane. All right, so the formulas I'm going to use to find distance are Pythagorean theorem. And then angles, how do I prove angles are not 90? That means I need to find the slope because I need to check if I flip it and change the sign, is it the same? If it's the same, it's a 90-degree slope. If they're not the same, then it is not 90 degrees. So that's my plan. So whenever you're starting a proof, you're going to write down your plan. So what are my sides? So DC. Now in geometry, you're going to put this line over it. It means the line segment DC. Again, not important for algebra 1. For me, I just want you to find the distances. So DC has to be equal to, this side has to be equal to this side, which is what? CB. And again, you put this over it. It just means the segment, the line segment that, which has to be equal to BA with that line on top of it, which has to be equal to AD. Okay, so all these sides must be equal. So all sides are equal. That has to happen. And the angles are not 90. So these angles are not 90. I don't have to prove all of them. I just have to prove one of them isn't. So pick one. Doesn't matter which one you want. I'll pick this one right here. So I'll pick this angle here. All right, so what does that mean? The angle that is made from AD and DC is not 90. So I'd say slope, so I'll find the slope of AD and DC. The slope for those are not reciprocal. All right, if I can prove that, then I'm good. All right, so that's my plan. Okay, so it says show all of your work. That's what I'm gonna do. And then have a concluding sentence stating whatever you've proven and why it's true. So I'll come back to this because this will be my sentence proving it's true. So I need to find all my sides. So let's go ahead and do that, and you'll see why I'm gonna stick to Pythagorean theorem in just a second. So I'm gonna list this out. DC, I need to find DC, CB, BA, and AD. I need to find all those sides. So I already know Pythagorean theorem is going to be the square root of the a squared plus b squared. All right, so if you're not clear on what I'm doing at this point, you need to go to the previous video and get good at it before you come here, because on here, I'm just going to focus on putting all those questions together. All right, so finding DC. So here is DC right here. So this is making up my triangle, my right triangle for Pythagorean theorem, right? This is C because it's opposite from the 90-degree angle. So this is the hypotenuse. So that means this is A and B. And the order of how I put this does not matter. So this is 1, 2, 3, 4, 5. All right, so this is 5 squared. So I'm going to put the number 5 here so I know that's there. And this is 1, 2, 3, 4, 5. So this is also 5. I'll put it up here. So that's also 5 squared. So Pythagorean theorem is a squared plus b squared square rooted will give you c. Okay, so 5 squared plus 5 squared square rooted. So this is the square root of 50, which again, let me show you in the calculator how to simplify it. All right, so let's go ahead and simplify a radical 50. So again, I'm putting it in the calculator just so you can keep track of this decimal to make sure we're right. So how do I do that? I break down 50 by dividing by prime numbers. So I'm going to check 2. It works. So I'm going to replace 50 with 2 times 25. And as long as that number stays the same, I'm okay. All right. Let's break down. So this is now a prime number. Let's break down 25. So we're going to check 25. It doesn't work with 2. So you go to the next prime number, which is 3. Doesn't work with 3. Go to the next one, which is 5. It does work with 5. So I'm going to replace 25 with 5 times 5. And it should give me the same thing. So 5 times 5. And you see the decimals, the irrational number is still the same. So what do you notice now? I have a book of what? 5, right? So remember, 2 cards make how many books? 1. So that's going to be 1 book outside. You see how my decimal did not change? So radical 50 is the same thing as saying 5 radical 2. This is a simplified version, but you guys remember, if you just put radical 50, you're going to get the question wrong. You have to simplify radical. So get comfortable with, breaking it down and then asking yourself how many books are these and taking them out. So all of these sides, if they're 5 radical 2, then we're halfway in proving that this is a rhombus. So let's do CB. So CB, horizontally, that's 1 box. And vertically, it goes from 2 to 9, which is 7. Feel free to count the boxes, but sometimes I use these numbers. All right, so again, a squared plus b squared, square rooted. So 1 squared plus 7 squared, which is equal to 1 squared is 1, 7 squared is 49, 49 plus 1 is the square root of 50, which is the same thing. So this is 5 radical 2. So far, I've proven DC is congruent or equal to CB. And these ticks, you're going to get very used to seeing them in geometry. All it means is they're equal. If it's the same tick, it's equal. All right, now I'm going to do BA. So this from here, it goes from 2 to 3. So that's 2 boxes to 0, another 3 boxes. So that's 5. Again, feel free to count that. Then from here, it goes from 4 to 1. So that's 5 boxes. Again, you can just count the 5 boxes. A squared plus B squared equals C squared. So square root of A squared plus B squared is equal to C. So 5 squared plus 5 squared is my Pythagorean theorem. And that's the same thing as we had up here. So that's going to give me the same thing. So radical 50, which is 5 radical 2. So far, this is also congruent or equal. Congruent is another word for equal in geometry. All right, so then we have AD. So this distance here is 1, and going up it starts at -3, that's 3 to 0, plus another 4 is 7. But again, you can count the boxes. All right, so that's going to be 1 squared plus 7 squared, 1 squared plus 7 squared, all square rooted. And you can see it's the same as this, which is going to give you radical 50, which is 5 radical 2. So we have just proved that all the sides are equal. So we're halfway through our proof. So the final thing is we need to look at the slope that they're not reciprocals. If there are reciprocals, they're 90 degrees. If they're not, they're not. So AD. So what is the slope for AD? Another cool thing for doing it with Pythagorean theorem as opposed to the distance formula is that you've already written the slope out. Remember, slope is rise and run, right? So where's AD? AD. Here's AD. I'm going to rise the 7 and run the 1 because 7 is vertical. So I'm going to rise 7 and then run left 1. So run 7, so up 7, down 1, so that's going to be negative. So that's going to give me -7 for the slope of AD. The slope of DC, so again, it's already listed out here. From D to C, I'm going to rise +5, run +5. So this is going to be 5 over 5, which is going to be equal to 1. And the question is, are these reciprocals? If I take this and flip it and change that sign, if I take this, flip it, it'll be 1 over 7. Change the sign will be +1 over 7. Is this +1 over 7? No. So these are not reciprocals. So not reciprocals. All right, so which means not 90 degrees. All right, so I just proved that this is a rhombus because, and now here's my, have a concluding sentence stating what you have proven and why it's true. So here's my concluding sentence. All right, so it is a rhombus because all sides are equal to 5 radical 2, and DC is not perpendicular to AD. All right, so again, you draw your picture, make a plan, show your work, and then have your concluding sentence that proves it. Okay, which is prove that it has a 90 degrees. So what does that mean? Again, that the reciprocal, when you flip it and change the sign, they're equal. So they have reciprocal. All right, so draw the figure is the first thing. So -6, -7, -6, -7. Label that W. -5, -3. Label that X. And then 3, -5. Label that Y. All right, so here's my triangle, and the question is, prove that it's a right triangle. What that means is it has an angle that's 90. Okay, which angle looks like it could possibly be 90? This one. All right, so again, I need to prove that the slope for this line and this line are reciprocals of one another, meaning if you flip and change the sign, they're reciprocals. All right, so let's write down the plan. So the plan is to prove that XW is perpendicular, and again, you're going to really learn this in geometry. Perpendicular, this is how you denote that, to this line right here, which is XY. So if I prove that they're reciprocals to one another, then it is a right triangle because it has a 90 degrees. So let's find the slope. All right, so I'll say slope of that. So let's do that. So slope of XW, and then we need to find the slope of XY. All right, which means I need my rise and my run. So how far am I rising? How far am I running? So let's do this one. So I'm going to rise 1, 2, 3, 4, and I'm going to run 1 positive. So this is 4 over 1 for XW. For Y, I'm going to rise 1, 2, and then I'm going to run 3 plus another 5, which is 8. Okay, so I'm going to rise 2 and run to the left, so -8. So if I simplify this, and you just put this right up in the calculator, it's going to give you -1 over 4. So the question is, are these two reciprocals? So let's take the top one. If I flip it, it's going to be 1 over 4. Change the sign, it's going to be negative. Is -1/4 the same thing I have here? It is. So these are reciprocals of one another, which means that this is a 90-degree angle. So here's the concluding sentence. XW is perpendicular to XY. Therefore, it is a right triangle. Okay. So you need to get used to putting certain concepts together, because that's actually what geometry is going to be. You're going to put multiple concepts together in order to answer one question. All right, so go ahead and complete the other two questions. So that question right there and that question right there. Let's practice.